Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about interrupts examples. So interrupt is something that will be interrupted a main program and executes the important tasks. For example, if we have a main system, so whenever the fire is detected, it given to the interrupt. So once that interrupt is detected, it need to turn on a siren. So whenever that fire sensor detected fire, it immediately informed through the interrupt. So once this interrupt is received, the current program is stopped and then interrupt program will be executed. Look at an example. This is the interrupt program. So this is actually main program and this is the interrupt program. So we are taking this ISR, interrupt service routine. So once the interrupt occurs, this interrupt service routine will be executed. After that completing this, so it have this return from an interrupt, RETA, return from interrupt. It go for it wherever it will be called. So during this execution, at any time interrupt may occur. So for example, during this instruction or during this instruction it may occur. So once that interrupt occurred, so the current execution will be stopped from here itself and it go for this interrupt service routine execution. After completing where it stopped, for example it is stopped here, it come back to this and it continues the main executions. So we can see both programs line by line. Look at this first instruction is move a comma hash 2. So that 2 is a immediate value that will be moved to accumulator. Look at the second one, move b comma hash 16. So the 16 is another data that will be moved to B register. Now I am performing MULAB. That means the A and B register value will be multiplied. This 2 and 16 is multiplied. So actually 2 and 16 are 8-bit data. Once if you multiply, you get a 16-bit data. So lower bit will be available in accumulator, higher bit will be available in a B register. So I am going to store the values, move R0 comma A, lower 8 bit will be stored to R0, move R1 comma B, higher 8 bit will be stored to R1 registers. Now I am going to perform another multiplication. Look at this, move A comma hash 12, so 12 is moved to accumulator, move B comma 20, this 20 is moved to B register. Again I am going to perform this multiplication of AB. This 12 and 20 will be multiplied. After multiplication, the results will be available in both accumulator and B registers. So look at this. After this, I am adding A comma R0. So A have a lower bit of this multiplication and R0 have a lower bit of first multiplications. So these two value will be added. So add A comma R0. Again that result is moved to R0 because I cannot hold any values in accumulator because for next addition multiplication I need to use accumulator. That's why after this I am moving the same data to R0. Now move A comma R1 that is the first multiplication higher 8 bits. Now the second multiplication higher 8 bit will be available in B register. That's why I am going to perform this. So once this move A comma R1 and add with carry. So I am not using add. Add means only an 8-bit addition. I am going to perform add with carry because already we have added two numbers here. That is this multiplication lower 8-bit and this multiplication lower 8-bit will be added. There may be carry. That carry also should be included. That's why I am using this ADDC. That means that lower 8-bit results will be added. That carry plus this higher 8-bit results will be added. Look at this, A comma B is loaded. So A have an R1 register value and B have an this second multiplication higher 8 bit. So both multiplication higher 8 bits will be available here. These two will be added with carry. After addition, I am storing the value to R1. So move R1 comma A and this is A. So this is the actual program. So simply we can say it's we have two numbers, that is a two 8-bit numbers that will be multiplied. So here this is the one multiplication and this is another multiplication. So these results will be combined and that will be moved to R0 and R1. So this is the actual main program. Look at this interrupt service routine program, what is available. The first one is increment R7. So it increments then R7 register. Then move A comma R7. This R7 incremented value will be moved to accumulator. Jump no 0 to next. So if there is a no 0, it will be moved to next. Else it will performs complement P1.6. So the port 1 sixth pin data will be complemented. Here we may connect some LEDs or some lights. So once this lines executed, that complements that particular line. So that means already the light is on, it will becomes off. Already off, it becomes an on. Again next, so once if it is a non-zero, it comes for a next, and that will be written from an interrupt. For example, if it is a 0, it will be execute this complement P1.6. Again, it come for this return, because here there is no another loop will be available. So once if we have this return instruction where it will be called, it will be go back there. So during this execution of this instruction, at any time there may be possible of interrupt occurs. So for example, during this execution of this MULAB, interrupt occurred means, so after this instruction, immediately it will be stopped and this ISR will be executed. After completing ISR, it will be have this written in from interrupt, it come for this line. So it starts executing from move R0, A. So the main program execution will be resumed after completing the interrupt service routine. Thank you.